Today, we're diving into some of the coolest tools in algebra. And no, I'm not talking about boring formulas you have to memorize. Think of these as math power-ups, shortcuts that are going to help you solve problems way faster and, honestly, make you feel like a genius. So, let's get started.
You've been there, right? You see something in parentheses with a little squared symbol and you just sigh knowing you have to write it all out and multiply every single term. But what if there was a pattern, a kind of secret code that makes the whole thing incredibly simple?
Well, there is. The official name for this whole process is expansion. It's just a fancy term for figuring out what's going on inside those brackets. And today, we're going to master all the shortcuts.
So let's start with the most important one of all. This is the foundation for pretty much everything else. You can think of it as the master key to algebraic expansions.
What's really great is that there's no magic here. It's just pure logic. If you look at how it's broken down, expanding a plus b squared just means you're multiplying a plus b by itself. You can see the steps. You multiply a by both terms in the second bracket, and then you do the same thing with b. It's just straightforward multiplication that leads us to a predictable pattern.
And here it is, the master key. The square of a sum is just the square of the first thing plus 2 times the first thing times the second thing plus the square of the second thing. Burn this pattern into your brain. I promise you it is going to pop up everywhere.
Okay, so how do we actually use it? Let's check out this example here. A plus 2b squared. We just follow the pattern. The first term, a, gets squared. Easy. Then we take 2 times the first term, a, times the second term, 2b, which gives us 4ab. And finally, we square that second term, 2b squared, which becomes 4b squared. You just stick it all together and you get a squared plus 4ab plus 4b squared. See? So much faster.
Awesome. Now that we have the master key, let's see how we can tweak it a little. You'll find there are a few simple remixes that let us handle slightly different but very common problems. Check this out. On the left, we've got our trusty master key. On the right, we've got the expansion for a minus b squared. Now look closely. Can you spot the difference? Yep, it's just one single minus sign. That is it. Instead of adding 2ab, you subtract it. The rest is exactly the same. Knowing that makes remembering both of them a piece of cake.
Now this is where it gets really interesting. What happens when you combine our first two power-ups? If you actually subtract the minus remix from the master key, something kind of magical happens. The a squared and b squared terms completely cancel each other out, and you're left with this super clean, simple result, 4ab.
Okay, but why does this combo even matter, you might be asking? Well, take a look at this next problem. We're given the values for a plus b and for ab, and we have to find a minus b. Now, you could do this the long way, but with our combo formula, we can just plug in the numbers we know, shuffle things around a bit, and solve for a minus b in just a couple of steps. It is ridiculously efficient.
All right, ready to level up? We're going from squares to cubes. Now, I know the expansion for a plus b cubed looks a little intimidating at first, but there's a really beautiful hidden symmetry in there. Just notice how the powers of a go down, 3, 2, 1, none, while the powers of b go up, none, 1, 2, 3. Once you see that pattern, it's so much easier to handle.
And of course, we can put this straight into action. In this example, we're expanding 2a plus 3b cubed. All we have to do is very carefully plug 2a in for a and 3b in for b in our cube formula. Yeah, it takes a few steps, and you have to be careful with your arithmetic, but the pattern itself does all the heavy lifting for you.
So far, we've only had 2 terms inside our brackets. But what happens when a third one, let's call it C, decides to join the party?
Well, the pattern just gets a little bigger, but it's still super logical. To square a sum of 3 terms, you start by squaring each one by itself. A squared, b squared, and c squared. Then you add 2 times the product of every possible pair. So you get 2ab, 2bc, and 2ca. Once you see the structure, it makes perfect sense.
And this formula is powerful enough to handle some pretty messy-looking expressions. Take this one, for example, 2x plus 3y minus 4z squared. The only trick here is to be really careful with that negative sign on the 4z. When you're calculating the paired up parts of the formula, that negative sign is going to carry through. But the core pattern, it holds up perfectly.
And you guessed it, just like our other power-ups, this one works in reverse too. So if a problem gives you the value of a plus b plus c squared and the value of a squared plus b squared plus c squared, you can easily work backwards to find the value of ab plus bc plus ca. It's an amazing problem-solving tool to have in your back pocket.
Okay, now it's time for the big payoff. This is why we've been gathering all these power-ups. We're going to use them to solve a classic algebra puzzle that looks almost impossible when you first see it.
Take a deep breath and look at this. The question is, if any three numbers add up to 0, you have to prove that the sum of their cubes is equal to 3 times their product. I mean, where would you even begin with that? It seems like it comes out of nowhere.
But the solution? Oh, the solution is just beautiful. It's shockingly simple. As you can see here, we just start by rearranging a plus b plus c equals 0 to get a plus b equals negative c. Then we cube both sides. We use our cube expansion power-up on the left, do a little bit of clever substitution and factoring, and the proof just materializes. It's so cool.
And the real reward for doing that proof is this. We can now solve certain problems in an instant. How would you calculate 8 cubed plus negative 5 cubed plus negative 3 cubed? I mean, that would take you a minute, right? Well, not anymore. Thanks to the identity we just proved, the first thing we do is check if the numbers add up to 0. Let's see. 8 plus negative 5 plus negative 3, yep, that's 0. That means the answer is simply 3 times their product. 3 times 8 times negative 5 times negative 3, which is 360. No big calculation needed. That is the power of these tools.
So here it is, your complete expansion toolkit. We've unlocked the master key for squares, we've leveled up to cubes, we've expanded to 3 terms, and we even solved a really clever puzzle with a special identity. These are the core power-ups you need.
You know, the biggest takeaway here isn't just the formulas themselves. It's the idea that they aren't just random rules somebody made up. They're patterns waiting to be found and used. They prove that even problems that look really complex on the outside often have a simple, elegant structure hiding just underneath. So the only